Hey guys, we are continuing solving problems from Fundamentals of Physics by Halliday Resnick Walker. We are solving problems from chapter 21, Electric Charge. And this time we will be doing problem number 28. Remember, we are using 8th edition. Okay. You will have same problem in your current edition with a different number. It will not be 28. For example, I know in the 9th edition, the same problem is having a number of 24. This problem is at 24th number. Okay, in my edition, 8th edition, it's at 28. You'll have maybe 10th or 11th edition. It will be there with a different number. Two tiny spherical water drops with identical charges of -1 into 10 to the power minus 19 Coulomb have a center-to-center separation of 1 centimeter. What is the magnitude of the electrostatic force acting between them? How many excess electrons are on each drop, giving it its charge imbalance? So we are having two drops, two water drops, small water drops. Both of them are having a charge of -1 into 10 to the power minus 16 Coulomb. They are separated by a distance of 10 to the power minus 2 meters. 1 centimeter is 10 to the power minus 2 meters. We have to find out force between them and then the number of electrons, extra electrons there. Force, we'll simply use Coulomb's law for that. F is equal to gamma Q1 Q2 divided by R squared. Which means F is equal to, let's substitute the values. Gamma is 9 into 10 to the power 9. Q1 is 1 into 10 to the power minus 16. Q2 is also 1 into 10 to the power minus 16. We're just using magnitudes of the charges because we're finding only magnitude of the force. Divided by R is 10 to the power minus 2 meters with the square. So this implies F is equal to, now I have worked out this thing, F comes out to be 9 into 10 to the power minus 19 newtons. So this is the force between the two drops. Okay, this is the force between the two drops. Now, in part B we have to find out extra number of electrons. So we start with two drops which are neutral. That means number of electrons and number of protons in each drop are same. So we'll have same number of electrons and protons in this drop, same number of electrons and protons in this drop. So charge is balanced, net charge is 0. Now we are supplying electrons to both of them. So these are the extra electrons these two drops are getting. With these extra electrons, they will get some negative charge. Okay, extra electron, we're supplying electrons. It will have excess of electrons, so it will have some negative charge. If you supply n electrons to it, it will have a charge of minus Ne. Same goes here. If you supply n electrons to this drop, it will have a charge of minus Ne. And that charge is given to you, Q is equal to minus Ne, Q is equal to minus Ne for both the drops. And that charge is given to you is -1 into 10 to the power minus 16 Coulomb. You just have to find out N. Okay, you just have to find out N. So Q is equal to Ne. Or N is equal to Q divided by E. Q is 1 into 10 to the power minus 16 Coulomb. I'm just using the magnitude. Yes, 1 into 10 to the power minus 16. Divided by E is 1.6 into 10 to the power minus 19. So this implies N is equal to, now you have to work out this thing. I have already done that. 625 is the number of extra electrons. So each drop will have excess number of electrons. Each drop will have 625 excess electrons. One is electrons it already had, but that doesn't give it any net charge because those number of electrons is same as the number of protons there. This is the extra number of electrons in each drop which gives it a charge of 1 into 10 to the power minus 16 Coulomb. Okay, is that fine?